welcome to Unit 6, Similarity, topic number 2. We're going to talk about proportional relationships, okay? So remember, last class we learned about what a ratio was. A ratio was a comparison between two different quantities. So what we can say is we can say two ratios are proportional if the ratios are equal, okay? If they're the same ratio, all right? We're going to go through this example first. I'll give us the second definition after. So let's look at example number 1, or A. It says, do the following ratios form a proportion? That's another way of saying, are they proportional? Okay, so be able to recognize both type of wording. Okay, so our goal is to see if the ratios are equal. The first ratio that we have is 4/5. If I'm looking at 20 over 25, I can try to simplify that ratio, or the fraction, and see if it actually simplifies down to the same ratio. So 20 and 25 have a common factor of 5. So divide the numerator and denominator by 5, and I get 20 divided by 5 is 4, 25 divided by 5 is 5. And notice, these were actually the same ratio, okay? So my answer would be, do the following ratios form a proportion? I would say yes, because the ratios are equal. Okay? Another way that we can show that two ratios are proportional is to see if they have the same scale factors. All right, and so we learned about scale factors last class. So scale factors are the number that multiplies one number of the ratio, one part of the ratio to the other part. So I'm going to write these ratios a little bit bigger down here, 4 over 5 and 20 over 25. And let's just prove that this is true. Let's prove they have the same scale factor. So if I want to say 4 times what gets me to 5, I'm going to do 5 divided by 4. And that gives me 1.25. So there's that scale factor. Okay? In the same direction, if I want to say 20 times what is 25, I'm going to do 25 divided by 20, and that's also 1.25. So notice, in the same direction, small number to big number, they have the same scale factor. Now let's check the other way. If I want to know 5 times what is 4, I'm going to do 4 divided by 5, that's 0.8. And then I'll check the other way. If I want to say 25 times what is 20, I'll do 20 divided by 25, and I get 0.8 as well. Okay? So notice, in both directions, they have the same scale factor. That's another way to show that the ratios are proportional. Okay? Let's actually use that method for part B. Okay? Because realistically, if one way was 1.25 in both ratios, the other scale factor is always going to be the same. So in reality, you only have to check one. Okay, so let's look at 12 divided by 5, and let's look at 14 divided by 10. If I do 12 divided by 5 on the calculator, I get 2.4. That means this scale factor, 5 times 2.4, will get me to 12. Now let's do 14 divided by 10 on the calculator. 14 divided by 10 is 1.4, so that means that 10 times 1.4 gets me to 14. These scale factors are not the same, so these ratios are not proportional. So another explanation I could say would be no, because the scale factors are different. And to prove this, the way that we did in our last example, let's simplify 14 over 10 as much as we can. I think we can divide this by 2. And notice that would simplify down to 7 over 5, which is not equivalent. 12 and 7 are my numerators. Those are not the same, okay? So we've proved it the other way as well. All right? Good luck on your homework, and I will see you in class tomorrow.